Hi, and welcome back to Wonder. In this video, we'll continue our journey on learning programming in Java. We'll go through Codecademy's second Java course, Variables. I'll put the link to this course down in the description, right under the like button, so that you can follow along and learn with me. This will be the second video and the second course in our Learn to Code Java playlist. And if you haven't seen our previous video, I would strongly advise you to go watch that one first and then come back to this video. I'll link this video in the description as well. If you're interested in more content like this, please consider subscribing for future videos. That being said, let's get started. Introduction. Let's say we need a program that connects a user with new jobs. We need the user's name, their salary, and their employment status. All of these pieces of information are stored in our program. We store information in variables. Name locations in memory. Naming a piece of information allows us to use that name later, accessing the information we stored. Variables also give context and meaning to the data we're storing. The value 42 could be someone's age, the weight in pounds, or the number of orders placed. With the name, we know the value 42 is age, weight in pounds, or number of orders placed. In Java, we specify the type of information we're storing. Primitive data types are types of data built into the Java system. The three main primitive types we'll cover are int, double, and boolean. This lesson will introduce these built-in types and more. We must declare a variable to reference it within our program. Declaring a variable requires that we specify the type and name. The name of the variables above are age, salary requirement, and is employed. These variables don't have any associated value. To assign a value to a variable, we use the assignment operator equals. Age equals 85. Now age has a value of 85. When code is used to represent a fixed value, like 85, it's referred to as literal. It's also common to declare a variable and assign it a value in one line. For example, to assign 2011 to a variable named year Codecademy was founded, of type int, we write int year Codecademy was founded equals 2011. Okay, instructions. In creator.java, we have defined some variables related to James Gosling, the creator of Java. Inside main, use system.out.println to print out the variable name. Okay, so inside these, we must print the name defined as James Gosling. Then we'll just write system out println name. Try that and hit run. Perfect. Now use the same command to print out year created. Okay, so here you can see year created is 1995, but we just type system out println year created. Try and hit run again. Perfect. Let's go to the next task. Ints. The first type of data we will store is the whole number. Whole numbers are very common in programming. You often see them used to store ages or maximum sizes, or the number of times some code has been run, among many other uses. In Java, whole numbers are stored in the int primitive data type. Ints hold positive numbers, negative numbers, and 0. They do not store fractions of numbers with decimals in them. The int data type allows values between this and this number. To declare a variable of type int, we use the int keyword before the variable name, as you can see here. Instructions. The file countComment.java has a number of comments in it. In your head, count the number of comments, then inside the main method, declare a variable called numComments that holds how many comments you counted. Okay, so let's start with counting the comments. So there's 1, 2, 3, 4, 5, 6. Okay, then inside main, in between these, let's declare a variable. Then we must type int called num comments equals, I counted 6, and then a semicolon. Let's try to hit run. Perfect. Num comments. Okay. I'll just type system out print ln num comments, then a semicolon, hit run, and it prints 6. Perfect. Let's go to the next task. Doubles. Whole numbers don't accomplish what we need for every program. What if we wanted to store the price of something? We need the decimal points. What if we wanted to store the whole world's population? That number would be larger than the int type can hold. The double primitive data type can help. Double can hold decimals as well as very large and very small numbers. The maximum value is this number, which is approximately 17 followed by 307 zeros. The minimum value is 4.9e minus 324, which is 324 decimal places. To declare a variable of type double, we use the double keyword in the declaration. Like this. Instructions. As of 2016, Android has 81.7% of the market share for mobile operating systems. Create a variable called Android share that holds this percentage as a double. So let's type in double Android share equals 81.7%, and then this. Let's try to hit run. Perfect. Print out Android share to the console. Okay. System out print ln Android share semicolon. Hit run again. Let's print 81.7. Perfect. Let's go to the next task. Booleans. Often a program faces questions that can only be answered with yes or no. Is the oven on? Is the light green? Did I eat breakfast? These questions are answered with a Boolean, a type that refers to one of two values, true or false. We declare Boolean variables by using the keyword Boolean before the variable name, like you can see here. In future lessons, we'll see how Boolean values help navigate decisions in our programs. Instructions. Create a variable called int can hold decimals. Set it to true if the int type can hold a decimal number. Set it to false if the int type cannot do this. Okay, so let's type in Boolean int can hold decimals. Let's set it to false because ints cannot do this. And a semicolon, try to hit run. That worked. Now print out your ints can hold decimals variable. So let's type system out print ln ints can hold the symbols. Hit run. Perfect. Let's go to the next task. Char. How do we answer questions like what grade did you get on the test and what letter does your name start with? The char data type can hold any character, like a letter, space, or punctuation mark. It must be surrounded by single quotes, like this. For example, char grade equals A, char first letter equals B, char punctuation equals this. Okay, instructions. Create a variable called expected grade of type char. Fill it with a single letter representing the grade you think you would get in a graded Java course where the grades A, B, C, D, and F are possible. Okay, so let's type in char expected grade equals, let's type in B, for example, and end it with a semicolon. Hit run. Perfect. Print out your expected grade variable. Okay, so let's type in system out print ln expected grade. Let's run, and it prints out B. Let's go to the next task. String. So far, we have learned primitive data types, which are the simplest types of data with no built-in behavior. Our programs will also use strings, which are objects instead of primitives. Objects have built-in behavior. Strings hold sequences of characters. We've already seen instances of string, for example, when we printed out hello world. We printed out hello world in the previous course, which is also the previous video of this playlist. I will link this video down below in the description, so if you haven't seen that one already, feel free to check it out. Anyways, there are two ways to create a string. Using a string literal or calling the string class to create a new string object. A string literal is any sequence of characters enclosed in a double quote, like this. Like primitive type variables, we declare a string variable like by specifying the type first, like this. We could also create a new string object by calling the string class when declaring a string like so. There are subtle differences in behavior depending on whether you create a string using a string literal or a new string object. We'll dive into those later, but for now, we'll almost always be using string literals. Keep reading AP Computer Science students. Certain symbols, known as escape sequences, have an alternative use in Java print statements. Escape sequences are interpreted differently by the compiler than other characters. Escape characters begin with this character, right here. There are 3 escape sequences to be aware of for the AP exam. This escape sequence allows us to add quotation marks to a string value, like you can see here. If we didn't use an escape sequence, then Java would think we're using the quotation marks to end the string. Using this escape sequence allows us to place backlashes in our string text, as you can see here. This is similar to the last example, just like this usually has a special meaning. In this case, this is used to start an escape sequence. Well, if we don't want to start an escape sequence and just want this one in our string, then we'll use this. We're using an escape sequence to say that we don't want this to be interpreted as the start of an escape sequence. It's a little mind-bending. Finally, if we place this escape sequence in a string, the compiler will output a new line of text. So this prints hello goodbye. Okay. You can think of this as the escape sequence for new line. Instructions. Create a variable called opening lyrics that holds yesterday all my troubles seemed so far away. So we'll write string opening lyrics yesterday all my troubles seemed so far away. Let's try to run. Call system out println to print out the opening lyrics. Okay. Let's add a white space and type system out print ln opening lyrics. And it prints yesterday all my troubles seemed so far away. Perfect. Let's go to the next exercise. Static checking. The Java programming language has a static typing. Java programs will not compile if a variable is assigned a value of an incorrect type. This is a bug, specifically a type declaration bug. Bugs are dangerous. They cause our code to crash or pronounce incorrect results. Static typing helps because bugs are caught during programming rather than during execution of the code. The program will not compile if the declared type of the variable does not match the type of the assigned value. The string hello world cannot be held in a variable of type int, like here. For the example above, we see an error at the console at compilation, like this. When bugs are not caught at compilation, they interrupt execution of the code by causing runtime errors. The program will crash. Java static typing helps programmers avoid runtime errors, and thus have much safer code that is free from bugs. Instructions. In the math.java file, we have declared a bunch of variables with the wrong type. Try to compile the file using the command javac math.java. Okay, so let's type in javac math.java. Hit enter. Okay. Change the type of the variables so that they can correspond with the type of the assignment values. For example, year is assigned 2001, so it should be an int. Okay, so let's change this one to int. This one should say string. This one should say char. This one is a double. Finally, this one is a Boolean. Let's try to run again. Perfect. Compile the file again. Look at how it compiles with no errors now. Java C math.java. Enter. No errors. Perfect. Let's go to the next task. Naming. Let's imagine we're storing a user's name for their profile. Which code example do you think is better? String data equals Delila or string name of user equals Delilah. While both of them will compile, the second example is way more easy to understand. Readers of the code will know the purpose of the value, Delilah. Naming variables according to conversation leads to clear, readable, and maintainable code. When someone else or our future self reads the code, there is no confusion about the purpose of a variable. In Java, variable names are case sensitive. So my height is a different variable from my height. The length of a variable name is unlimited, but we should keep it concise while keeping the meaning clear. A variable starts with a valid letter, or this or this. No other symbols or numbers can begin a variable name. One as the place and this geyser are not valid variable names. Variable names of only one word are spelled in all lowercase letters. Variable names of more than one word have the first letter lowercase, while the beginning letter of each subsequent word is capitalized. This style of capitalization is called camel case. Instructions. In the badnames.java file, we declared variables with confusing names. Run the file and look at the error message you get when you try to compile. Some of these variable names are illegal. Change the one that are preventing the file from compiling. So this one, for example, we can see is not allowed. So let's change this one to first name equals mirror. Allowed, that one's allowed. This one is not allowed, so let's just remove this one. This one is allowed, and this one is also allowed. Let's try to run it again. The program runs. Perfect. Let's go to the last task. Review. Creating and filling variables is a powerful concept that allows us to keep track of all kinds of data in our program. In this lesson, we learned how to create and print several different data types in Java, which you'll use as you create bigger and more complex programs. We covered int, which stores whole numbers, double, which stores bigger whole numbers and decimal numbers, Boolean, which stores true and false, Char, which stores single characters using single quotes, string, which stores multiple characters using double quotes, static typing, which is one of the safety features of Java, and variable naming conversation. Practice declaring variables and assigning values to make sure you have a solid foundation for learning more complicated and exciting Java concepts. Instructions. The file myprofile.java contains a class that represents your hiring profile as presented to potential employers. In the main method, create a variable called name that holds your name as a sequence of characters. And when it's a sequence of characters, we use the string one. So let's type in string, then name. And your name, in my case, that's Thomas. Hit run. Next, create a variable called age that holds your age as a whole number. And whole numbers, we use int. So let's type int age equals, in my case, 19. Hit run. Third, create a variable called desired salary that holds your desired salary per year to a precision of 2 decimal points. When we use decimal points, we must use this one, double, as you can see here. So let's type in double, and then this. salary equals, let's just put like 95,000. Hit run. Fourth, create a variable called gender that holds a single character, M for male, F for female, N for none, or O for other. And when it's a single character, we use this one, Char. Char gender equals, in my case, this one, M for male. Hit run. And finally, create a variable called looking for job that holds whether or not you are currently open for job offers. And in this case, we have to use this one, Boolean, because it's one of two options. Let's type in Boolean and then looking for job equals, let's just say true. Hit run. Perfect, all done. And with that, our second Java course is done. If you found this course hard to understand, I would advise you to go watch the video one more time, and then I'm sure it will make more sense to you the second time. If you found this course easy, however, I would advise you to watch our video on the next Java course from Codecademy. You'll find this video in the description as well. Save this video for another time and share it with your friends, colleagues, or family. Please consider subscribing, it's free and you can unsubscribe at any time. If you found this helpful, I would really appreciate it if you left a like on the video, and feel free to ask me any questions in the comment section below, and I'll do my best to answer them. I hope to see you in the next video, but until then, have a great day.